Imagine standing inside a modern home and realizing that almost every wall around you began as ordinary rock pulled from the ground. Think about this. Every year, billions of square feet of drywall are produced. Yet most people never stop to wonder how a powdery mineral transforms into the smooth walls that surround their lives. The journey involves giant mines, roaring machines, temperatures hotter than a pizza oven, and production lines stretching hundreds of meters. But here's what nobody tells you. The secret ingredient inside your walls has been used by humans for thousands of years. Right now, somewhere in the world, massive conveyor belts move tons of crushed gypsum every minute. Powerful grinders shake entire factory floors. Automated systems monitor every second of production with incredible precision. And what happens next surprised even experienced engineers, because the material inside drywall undergoes a transformation that looks almost like magic. Today, we're following drywall from deep underground mines to the finished panels installed in homes, offices, hospitals, and skyscrapers around the globe. You'll see how raw stone becomes one of the most important construction materials ever invented. And near the end of this journey, you'll discover a quality test so brutal that only the strongest boards survive. But first, we need to travel to the place where everything begins. The main ingredient in drywall is gypsum, a soft sulfate mineral made of calcium sulfate and water molecules. Some of the world's largest gypsum deposits lie beneath regions of the United States, Canada, Spain, Mexico, China, and Thailand. In many mines, the gypsum layer stretches for kilometers underground like a hidden white ocean trapped beneath the earth. Most drywall manufacturers require gypsum purity levels above 80 to 90% before processing even begins. Miners use powerful drilling machines to create patterns of holes across the rock face. Controlled blasting breaks apart thousands of tons of gypsum in seconds, sending shockwaves through the mine. The sound is thunderous. The air fills with fine white dust. Within hours, gigantic loaders begin collecting the broken material and transporting it toward crushers waiting nearby. Photorealistic, cinematic, ultra-detailed, 8K, industrial documentary style, gypsum mine blasting operation with controlled explosion, giant loaders collecting freshly broken white rock, dust clouds illuminated by dramatic lighting, orange and blue industrial color grading, wide-angle lens, depth of field, highly detailed mining equipment. But natural gypsum isn't the only source. Modern factories increasingly use synthetic gypsum recovered from power plant emission control systems. What once left smokestacks as pollution can now become part of a finished wall panel. This recycling process diverts millions of tons of material from waste streams every year. It's one of the most surprising supply chain secrets in the construction industry. Next comes another critical ingredient: paper. The front and back surfaces of drywall rely on specially engineered recycled paper liners. Giant paper mills process mountains of recovered cardboard and paper waste into enormous rolls weighing several tons each. These rolls will eventually move through the factory at astonishing speeds, forming the skin that gives drywall much of its strength. Manufacturers also add starch, foam agents, fibers, accelerators, retarders, and performance-enhancing chemicals. Some formulas improve fire resistance. Others reduce weight or increase durability. A single drywall recipe may contain more than a dozen carefully measured ingredients. And this is where it gets truly extraordinary, because once those ingredients meet inside the factory, a non-stop manufacturing process begins that can produce thousands of boards every hour. What happens next transforms powder, paper, water, and chemistry into perfectly engineered wall panels. Temperatures rise, machines accelerate, precision becomes everything, and one mistake measured in millimeters can ruin an entire production run. Let's step onto the factory floor and watch drywall come to life. The moment gypsum arrives at the factory, the first transformation begins. Giant crushers reduce large chunks of rock into smaller pieces before sending them into grinding mills. Inside these mills, rotating equipment spins at speeds that can exceed 1,000 revolutions per minute, turning solid mineral into a fine powder. The sound is relentless, a deep mechanical roar mixed with the hiss of moving material, and the air carries the dry scent of freshly ground stone. Next, the powdered gypsum enters massive calcination kilns. Here, temperatures typically reach between 150 degrees Celsius and 180 degrees Celsius, or about 302 degrees Fahrenheit to 356 degrees Fahrenheit. During this stage, part of the water trapped inside the gypsum crystal structure escapes as steam. Think about this. A simple heating process changes the mineral's chemistry and prepares it for one of the most important reactions in drywall manufacturing. White vapor rises from the equipment while sensors constantly track every degree of temperature. After calcination, the material becomes a form known as stucco. The powder travels through enclosed conveyors toward high-speed mixers. Here, operators combine it with water, starch, foam, fibers, and specialized additives. The mixture moves fast, often completing the blending process in less than a minute. What looks like an ordinary slurry now contains the recipe for a board strong enough to become part of homes, schools, and skyscrapers. And this is where the production line suddenly comes alive. A continuous sheet of recycled paper unwinds from a massive roll and races forward through the factory. Some production lines move at speeds exceeding 60 meters per minute. The wet gypsum mixture pours onto the paper in a perfectly controlled layer. Seconds later, another paper sheet folds over the top, creating what looks like a giant industrial sandwich stretching toward the horizon. And this is where the production line suddenly comes alive. A continuous sheet of recycled paper unwinds from a massive roll and races forward through the factory. Some production lines move at speeds exceeding 60 meters per minute. The wet gypsum mixture pours onto the paper in a perfectly controlled layer. Seconds later, another paper sheet folds over the top, creating what looks like a giant industrial sandwich stretching toward the horizon. As the board continues moving, precision forming stations control its thickness with incredible accuracy. Standard drywall often measures 12.5 millimeters or half an inch thick, and tolerances may vary by only a fraction of a millimeter. Automated rollers shape the edges into the familiar tapered profile used by construction crews worldwide. Every second, sensors verify dimensions to ensure consistency across the entire sheet. The continuous ribbon of drywall now stretches for hundreds of meters. Then comes a moment of perfect timing. Automated cutters slice the moving board into exact lengths, often ranging from 2.4 to 4.8 meters, while the line never stops moving. Imagine trying to cut a speeding object with millimeter precision thousands of times every day. Yet these systems perform the task with remarkable consistency. But the boards are still far from finished. Fresh drywall contains significant moisture, and removing it requires enormous drying ovens. The panels enter multi-level dryers where temperatures commonly range from 180 degrees Celsius to 230 degrees Celsius, or 356 degrees Fahrenheit to 446 degrees Fahrenheit. Hot air rushes through the chambers for 30 to 60 minutes depending on thickness and product type. The heat feels intense, the airflow sounds like a jet engine, and the smell resembles warm paper mixed with freshly baked minerals. When the boards emerge from the dryer, they look remarkably similar to the finished product you see in building supply stores. But here's what nobody tells you. At this stage, hidden defects can still ruin an entire batch. Tiny cracks, density variations, or paper bonding issues may remain invisible to the human eye. And that sets the stage for one of the most sophisticated quality control systems in modern manufacturing. In the next stage, lasers, cameras, sensors, and experienced inspectors work together to catch flaws before a single board reaches a customer. Some defects measure less than a millimeter. Others hide deep inside the panel itself. What happens next determines whether the drywall earns approval or gets rejected and recycled back into the process. The moment a drywall board leaves the dryer, it enters a world where almost nothing escapes inspection. Overhead cameras capture thousands of images every minute. Laser scanners sweep across every surface, measuring dimensions with astonishing precision. Most people never think about this, but a defect smaller than the thickness of a credit card can trigger an automatic rejection. Modern drywall factories rely on networks of sensors connected to powerful industrial computers. These systems monitor moisture content, board density, edge geometry, paper alignment, and surface quality in real time. Imagine hundreds of measurements happening every second while thousands of boards move through the plant. What happens next surprised even experienced engineers because artificial intelligence now helps detect defects that human eyes might miss. AI vision systems compare every board against a digital model of perfection. The software searches for cracks, dents, bubbles, paper tears, thickness variations, and edge damage. Some systems can detect flaws measuring less than 1 millimeter. In a factory producing thousands of boards per hour, that level of accuracy prevents costly mistakes from reaching construction sites around the world. But here's what nobody tells you. Even the smartest machines cannot completely replace human experience. Veteran inspectors often recognize subtle warning signs that algorithms struggle to interpret. A slight change in texture, an unusual sound when a board is handled, or a barely visible paper irregularity can reveal a deeper problem. Sometimes decades of experience outperform millions of lines of code. Once visual inspections finish, destructive testing begins. Samples move into specialized laboratories where technicians measure strength, density, moisture resistance, and paper adhesion. Machines apply increasing force until the board bends, cracks, or fails. The sharp snapping sound echoes through the testing area. What seems like destruction actually protects millions of future buildings. Fire-resistant drywall faces even harsher examinations. Engineers expose samples to extreme heat inside specialized furnaces designed to simulate real building fires. Temperatures can exceed 800 degrees Celsius, or nearly 1,500 degrees Fahrenheit. As flames surround the board, sensors track performance second by second. And this is where it gets truly extraordinary because water trapped within the gypsum crystal structure helps slow the spread of heat. Factories also conduct dimensional verification tests. Laser systems confirm thickness, length, width, and edge geometry. Typical manufacturing tolerances often remain within fractions of a millimeter. If measurements drift beyond acceptable limits, automated controls immediately alert operators. In some facilities, rejection rates stay below 2% thanks to constant monitoring and rapid adjustments. Certification standards add another layer of scrutiny. Manufacturers often design products to meet strict requirements established by building codes and international testing organizations. Every approved board represents countless measurements, inspections, and documented quality checks. Most people only see a simple wall panel, but behind that panel lies an enormous system built around trust and consistency. After passing inspection, robotic handling systems take over. Automated lifts stack finished boards with incredible precision. Computer-controlled conveyors move tons of material without stopping. Some facilities operate 24 hours a day, producing enough drywall in a single week to cover entire neighborhoods. The scale is almost impossible to comprehend. After passing inspection, robotic handling systems take over. Automated lifts stack finished boards with incredible precision. Computer-controlled conveyors move tons of material without stopping. Some facilities operate 24 hours a day, producing enough drywall in a single week to cover entire neighborhoods. The scale is almost impossible to comprehend. Think about this. Every year, manufacturers around the world produce tens of billions of square feet of drywall. If those boards were placed end to end, they would stretch across continents and circle the planet many times over. Most people see drywall as an ordinary building material, but its global footprint rivals some of the largest industries on Earth. The scale is so vast that it becomes difficult to visualize. Today, the global drywall market generates tens of billions of dollars in annual revenue. Construction booms, urban expansion, and infrastructure projects continue to drive demand higher. Every new apartment building, office tower, school, hospital, and hotel requires enormous quantities of wallboard. What happens next may surprise you because demand continues growing even in regions where construction technology changes rapidly. The world's largest drywall-producing nations include China, the United States, India, Japan, and Germany. Together, these countries account for a substantial share of global production capacity. Massive manufacturing plants operate around the clock to satisfy local and international demand. Some individual factories produce enough drywall in a single day to cover hundreds of average homes. Did you know that modern drywall helped transform the construction industry by dramatically reducing building time compared to traditional plaster walls? Before drywall became widely available, workers often spent days applying multiple layers of wet plaster. Today, installation crews can cover large interior spaces in a fraction of that time. A construction revolution quietly unfolded behind ordinary walls. Here's another astonishing fact. Millions of people worldwide work directly or indirectly in industries connected to gypsum mining, paper production, transportation, manufacturing, construction, engineering, and distribution. Behind every finished drywall panel stands an enormous network of human effort. From miners deep underground to installers on high-rise construction sites, countless hands contribute to the final product. Did you know that some fire-resistant drywall products can slow the spread of flames long enough to provide critical evacuation time during emergencies? Most people never think about this hidden safety feature. Yet inside many buildings, specialized drywall acts as a silent protective barrier every hour of every day. Its importance often goes unnoticed until it becomes absolutely essential. Over the last 50 years, drywall manufacturing has changed dramatically. Production lines became faster, quality control became smarter, recycling programs expanded. Advanced additives improved performance while reducing weight. What once depended heavily on manual labor now relies on sophisticated automation, robotics, sensors, and artificial intelligence working together in real time. And this is where it gets truly extraordinary. Researchers are developing lighter boards, stronger cores, improved moisture resistance, and more sustainable production methods. Some future factories may use even greater levels of automation while reducing energy consumption and waste. The next generation of drywall could look familiar on the surface while containing decades of engineering innovation inside. But after billions of square feet of production, millions of workers, and decades of technological progress, the most remarkable fact remains surprisingly simple. A material that begins as soft mineral rock eventually becomes the walls that define the spaces where people live, work, learn, and create memories. And that brings us back to where our journey began. From deep underground gypsum deposits to advanced manufacturing plants, you've witnessed an incredible transformation. You saw giant mines, powerful crushers, precision mixers, high-temperature dryers, laser scanners, robotic systems, and rigorous quality testing. Every stage required engineering, chemistry, logistics, technology, and human expertise working together with remarkable precision. Most people walk past drywall every day without ever realizing the extraordinary journey hidden behind its smooth surface. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.